Welcome to another edition of the AMSAT Newsreel.
Thank you, Barry. I would also like to thank AMSAT NA for the opportunity to tell you about SSETI Express this morning. I know there has been presentation on SSETI Express to AMSAT NA previously by one of the other team members. So this is by way of an update. I'm sure you've heard some of this information before, and I've presented some of this myself at Microwave Update 2004. I am Sam Jewell, and I'm a member of the S-band team involved in SSETI Express. One of my other team members is in the audience at the moment, David Bowman, G0MRF. Now, the situation with regard to SSETI Express is that this is not an amateur satellite per se. It does not belong to AMSAT UK. It is a student satellite. The name that they've chosen has caused some confusion with the SSETI, but do note it is spelt with two S's, but it is a student satellite that we have been invited to become involved in. SSETI stands for Student Space Exploration and Technology Initiative, and this is part of a European-wide initiative to get students involved in building satellites. Now, I know there will be some of you who will say there are quite enough students out there building satellites, but this is a concerted effort to get students involved, and as a byproduct of that, we have seen quite a few of them expressing an interest in amateur radio, so it has that further byproduct for us. Who's behind SSETI? Well, first off, the organisation is STEC, the European Space Research and Technology Centre. They're located near Noordwijk in the Netherlands. And behind them are the European Space Agency, ESA. Sorry, I haven't got a burgundy one with AMSAT NA on it. Also behind it, a number of European universities who are lending their efforts to the satellite, and ourselves, AMSAT UK. This is the SSETI Express mission. It's an educational mission. The satellite itself actually will deploy 3 other satellites from within itself, CubeSats. It will act as a test bed and a technology demonstrator, and then the final function, the one which is of interest to us, it will function as a radio transponder for the rest of its mission. And what does that mean? Well, the satellite's being sent up with the express purpose. Oh, sorry, didn't mean that. Express. It's being sent up with the purpose of being a technology demonstrator for some future satellites. It will have on board an amateur transponder. When the functions that it's being sent up are completed, which hopefully will be within a month or two, it will be turned over to us for use as a transponder. So we're passengers on board. We're not building the satellite. We're building one of the packages. We've built one of the packages that are on board. This is a picture of SSETI Express. This was taken at STEC. Why STEC are involved, the Space Research Centre, is that they have an educational outreach arm, and it's that educational outreach arm that are building the satellite. Now, they're getting cooperation from within STEC. There are several of the specialists there who have been helping us, but it's not one of their satellites, it's an educational satellite, and I can't stress that enough. I said that it will contain 3 further satellites that will be launched, 3 small student satellites, X1V from Japan, UV from Würzburg in Germany, and N-Cube from Norway. Now, these will have their own missions that they will be involved in. I'm afraid I can't really tell you very much about them. I know that there's some tracking and so on involved. They will have downlinks that are within the 70 centimetre amateur band, and they will contain commercial amateur radio equipment as their radio payloads. These are the main payloads on board SSETI Express. There is an imaging camera, which you can see here, and there's an attitude adjustment motor. I guess this is really the main payload, and the purpose behind this payload is that the next satellite to be launched in this range is a GTO called SEO, and it will require attitude adjustment. So this is the test motor for that purpose. This is what's going up. This is what's really been taking all the effort at STEC, getting this motor sorted out. I think that they're pretty much there now with it. So on board, 3 more satellites behind little T-pod launch doors, which I'll show you in a moment, an imaging camera, and an attitude adjustment motor, and our S-band package. Here are some parameters of the satellite. It's relatively large, particularly compared with Echo. It's absolutely enormous. It weighs 80 kilo. It will be launched on a Russian launcher from Platesh in Russia. And the latest launch date that we've been given is now at the end of August. I can't put a precise date on it. We're already overdue for the launch, and that's because of some problems associated with the primary payload, primary satellite launch. This is actually, the launcher is carrying 2 satellites for SSTL, the Surrey Satellite Technology Company. We have bought launch space on board, or STEC has bought this space on board, but those satellites being the primary ones, they have to be right, and they unfortunately slightly delayed. Hence we have a launch now at the end of August, and everything's now looking pretty good for that launch. Coming now to the main package on board, the S-band transmitter. Why have we got an S-band transmitter on board? Very fortuitous for us. Graham Sherville, G3VZV, was at a meeting with the project manager from STEC, from SSETI Express, and they were talking in terms of what they required for an S-band downlink transmitter. The satellite main radio payload is on 70 centimetres, it's on 437 megahertz, it's only 9.6 kilobaud. The data rates that they were proposing were totally inadequate. They were proposing to carry a commercial S-band transmitter. When the particular university involved discovered the cost of space-qualified S-band packages, they effectively withdrew their offer to provide that package, which left the satellite without any S-band. Graham saw an opportunity there that we could provide an S-band package if we were allowed to use it for amateur purposes. It would be used initially for downlinking data from the primary experiments. When they had finished doing that, it would then be turned over to us. Graham said to them, made this offer. The offer was accepted. The downside of it was, hey guys, you've got 6 weeks in which to do this. That was fast, and it meant that we had to make some compromises with what we wanted to do. It's not the ideal package. It does work. And one thing which we're very proud of, it was the first fully completed package to actually be delivered to STEC. Probably more important was the AMSAT UK involvement. It was clear fairly early on that the project manager was being overwhelmed with the amount of work he needed to do. It's great having students, but they are involved in an academic environment. They're not available when you want them. Neil even resorted to taking their passports away from them when they arrived at STEC to do some work, so they couldn't go away again until they completed what they were doing. And you think I'm joking? This is the S-band transmitter. The housing was very kindly provided by a Polish university. They also provided the 3 S-band patch antennas that are on board, but they couldn't provide the transmitter because of the sheer cost. So this is the package we've been working with. Inside there is what AMSAT UK have been putting together. Now, everybody's aware that there are some UK satellites through USAT, but AMSAT UK traditionally have not built space hardware. This is the first time we've been involved, and we've been so pleased to have been involved, to have learnt the various things that you need when you're building equipment that's going into space. Okay, moving on to the next slide then. These are some early photographs. I said we had to deliver something in 6 weeks. This is what we actually delivered. We call this FlatSat. The team consists of Graham Sherville, G3VZV, as our project manager in the UK. My involvement was the S-band modulator and exciter, and over here the sensor board. This unit was provided by G3WDG. It's actually the flight spare off Echo. It's the same PA. The one that's going into space is actually another unit rather than the actual flight spare off Echo. But AMSAT NA very, very kindly offered that unit, and that moved us along a great deal. It's the only space-qualified part in the satellite. Down here we have the logic and control board. It's been called various things, including some words that I won't mention here. And that was designed and built in very short order by G7 OCD, Jason Flynn. Jason's one of these young, very, very clever guys. And here at the bottom is the switch mode power supply. That was built by David. David's a real expert in this area. The whole satellite runs off a 28-volt bus, so here we've got a multi-switch mode power supply in order to get our 8 volts, our 5 volts, and so on. This is the inside of the S-band transmitter. This is an absolute no-no. Here we are, the housing and a couple of the modules in there at an early stage. This is taken on the nylon carpet in my house. When the project manager saw that, he had kittens. Here's the exciter modulator, here's the PA, and over here the sensor board. And on the reverse side of the housing, we've got the interface board and power supply, and I think something else, can't remember. Okay. Oh, one other thing I should mention here. The satellite has 3 S-band patch antennas. Here we've got a 3-way splitter, so the power output from the amplifier goes into the splitter, and we've got one primary output, which is neg 3 dB, half the power going into the splitter, and we've got 2 neg 6 dB outputs. These are a requirement for the testing of the antennas and that they're on board from the university in Poland. They're not our idea. They're actually trying out some new patch antennas. They're very, very good. Excellent performance, but in my opinion it's not the ideal configuration. This will go off to the antenna, which hopefully will be looking at the Earth the majority of the time. Primary communications, 9.6 kilobaud on 437 megahertz using the specially space-qualified, if you can call it that, T7F transceiver, which is a very well-known design by Holger Eckert, DF2QF in Germany. An excellent transceiver, really very, very good, and he's built a new surface mount version, very small, and that was going to provide the primary communication. The problem was that with the amount of data that satellite now needed to downlink, it just was totally impractical at 9.6. So our transmitter provides 38.4 kilobit per second using G3RUH type data filtered modulation. So it will be FSK, data downlinking, and then when it switches over to voice band operation, because it will be a single channel flying FM repeater with 437 can't remember what it is, on the uplink, and 2401.840 megahertz single channel FM down. We would much, much, much prefer to have been flying a linear transponder, and I'll tell you a bit about that in a moment. But that's what we were effectively asked to provide for our involvement in this. So this is what we will be flying. Our transmitter consists of a 3-watt transmitter, a TNC7. Oh, that's what was on the other side. I knew there was something else there. It's a commercial TNC, a switch mode power supply, logic interface board, sensor board, and the 3-way antenna splitter. In voice, it can run in voice or data config. In data, 38.4 kilobits per second from the TNC2. and that'll be relaying the satellite experimental data. Voice on 437 megahertz uplink. CTCSS encoded with 67 hertz at the uplink. And we have a simple DTMF-based telemetry frame transmission, which will be transmitted every 2 minutes. It's actually 2 minutes and 12 seconds. Thank you. Told you it took 6 weeks to produce. Actually, some arguments it was actually 8 weeks. I maintain it was 6 weeks from the time I was told. Okay, I've told you about all of that. Progress to date, integration tests complete, vibration tests complete. That was the thing that really worried me. It really did. We sailed through that. EMC tests complete, fit check completed, vacuum and heat tests have just been completed. Few minor problems appeared in there. Hopefully they're being resolved. As we speak, we've got 2 members of our team over at STEC sorting out some of the remaining problems there. And hopefully by the end of today, we'll have an email that will say, OK, all's go. It was due to be integrated at the end of this month. I think that's now into June, because it needs to be ready to ship in June. These are the participants. Jason, who did the data side, Graham Sherville, project managed, David Bowman with the power supply, Howard Long, we drafted in to take care of the ground station side. It was absolutely obvious that the student side of this had no idea what was involved in ground stations, and certainly S-band scared the life out of them. Charlie Suckling. Charlie is kind of a sleeping partner in this. He provided the PA, he provides the support. We don't see him, but he's absolutely an integral member of the family. University of Wrocław in Poland provided our housing, and AMSAT provided some of the facilities for travelling. Most of this has been done off our own back, of course, but they've provided all the support, and whenever we've had a problem, they've been there to support us. If you want more information, this is the website to go and have a look at. I do urge you to have a look at it. This has got to be the most documented satellite in the public domain that any of you have ever seen. Every little wart, wrinkle is there in the integration logbook. I am extremely embarrassed about some of the things that are in that logbook. But hey, these things happened, they are logged, and we ain't going to get it wrong again, because I ain't going to be embarrassed like that again. And you can see a webcam. If you go to the ARRL booth or your own booth and have a look today, and you go to that website, have a look at the webcam, you'll actually see today's efforts getting some of the background problems being sorted out. The webcam almost certainly will be running, and they'll be sorting this out. Okay, that's me, just in case you need to get in touch with me. I will be on the AMSAT stand this afternoon between 3 and 4. If you need to talk to me at any other time, I'm out on the flea market, hopefully today getting warm. I'll be on stand 915 with Kent Britton. He's got a lot of little antennas there that may interest you if you haven't seen them before. And at that point, any questions? Sure.
What will be the receive polarization for the downlink?
For the downlink, it's circular. I think it's right-hand circular down. The uplink is linear. It uses just a simple monopole on top of the satellite, and again we learnt an awful lot of lessons about simple things like monopoles. Again, there are things there we wouldn't do again. The monopole on the uplink, incidentally, is a cut-down monopole off an earlier weather satellite, I understand. Yes, Rick?
I didn't see very many solar cells on the outside. What's the power budget for this?
A little over 20 watts, I think, currently. Is that correct, David? About 23 watts. There has been a lot of work gone into sorting out that side of it. Originally, it was going to fly with the solar cells from the ESA solar car that entered and won, I think it was the Trans-Australian thing a year or two back. We were going to have the solar cells. Do you know how many stone chips you pick up when you put solar cells on a car and drive it across Australia? So they had to find an alternative. Okay, any other questions?
Sam, just worth mentioning that I think ESA are going to release some software to enable amateurs to download some of the photos on their commercial side, and it's 1.3 megabyte size pictures.
Thank you for that, David. Yes, I completely forgot to mention. They will be releasing software. There will be a competition for data collection being offered. We've also, through Howard, put together our own software so that you can decode the relatively simple telemetry. Howard's done a really nice job of that. So we're continuing to support. Even after launch, there will be support for you to use. And we hope we're going to be on one of the follow-up satellites. And the thing I really wanted to mention here was that we have already got a linear transponder in development. David will be demonstrating that live, I hope, at the AMSAT UK colloquium at the end of July. Hopefully it's going to be very, very similar to the one that we fly, and also Howard's been doing a lot of work on DSP-IF functions. It may not go on the next satellite, but we've got the bit between the teeth now. There are things that we really want to get involved in, and that hopefully is going to be one of the next ones. If we can solve some of the power problems associated with flying DSP. Okay, thank you very much indeed.